Hey students, I know you're all super upset that I can't be there today, but luckily through the advances of technology, I can still teach you. I know, it's amazing. I am just as amazed. What you're going to be learning about today is the double and half angle identities in trigonometry. And like I said, when they didn't have calculators back in the day, this is what they would use to calculate different trig values. So for example, if I knew what the sine of 45 degrees was, right, which we do know, say it in your head, remember that's square root 2 over 2, I can use the double and half angle identities to find out, well, if I doubled this, what's the sine of 90 using the double formula, and I could also find out the sine of 22.5 using the half angle identity. So what are these formulas? Well, let's take a look at them. So first let's start with the double. These are the, nope, that's not what I wanted. Let's start with the double angles, okay? Now, listed up here are your double angle identities. What this is saying is, if I wanted to double my angle, how can I find it? All I'd have to do is plug into this formula. So basically what I would do is take 2 and multiply that by the sine of the angle times the cosine of the angle. If I wanted to double the angle and find out the cosine value, I would take the cosine squared of that angle minus the sine squared of that angle. And tangent, well, that's all that googly gop over there. Well, first, before we even get started into the mathematics, I want to do a little proof for you. And we're going to do that using the sum and difference identities that we already learned. Well, right here, we're just going to do a quick proof. Let's say I wanted to know what the sine of 2a was. All right, I want to prove this identity that you just learned. Well, the sine of 2a is the same thing, I think, as the sine of a plus a. I think we could all agree with that. 2a is the same as a plus a. Well, I could prove that this identity is true by using the sum and difference identity that we already learned yesterday. So what I'm going to do is plug that into this formula. So if I wanted to do the sine of a plus a, well, I'll just plug it into my formula. That would be the sine of a times the cosine of a plus, well, it's a again, the cosine of a times the sine of a. Well, how does that help me prove this identity right here? Whoa, whoa, whoa. How does that help me prove this identity right here? Well, let's take a look. I can say that the sine of a plus a is equal to, well, remember, multiplication is commutative, so I could just rewrite this as a sine a times cosine a. That stays the same. Plus, these two are commutative because multiplication, sine a, cosine a. And if you look a little closer, these are the same exact thing. So I could say the sine of a plus a is equal to 2 sine a cosine a. Boom, there's your proof. You didn't believe me, and there it is. Now I'm going to leave this on you to do this second proof right here, okay? Now I'm going to give you a clue. Just start with this. The cosine of a plus a is the same thing as the cosine of 2a, and you plug that into your sum identity to try to figure it out. Major props if you can do this. All right, let's move on to the half angle identities. These are our half angle identities. We got the sine of half the angle. Remember, this is our angle right here. Half of our angle would be equal to this, the positive or negative square root of 1 minus the cosine of that angle divided by 2. The cosine of half an angle is equal to plus or minus the square root of 1 plus the cosine of a, just a little different. And the tangent of half an angle, if I want to find half the angle, is this craziness. So just to test this out, let's just do a little test to see if these formulas even work. What I want to do is find half the sine of 60 degrees. All right, half of 60 degrees. So basically this is just saying that I want to find the sine of 30 degrees, right? Half the sine of 60 is really just the sine of 30 degrees, and we know that to be 1/2. Now let's see if this is actually true. What we're going to do is plug this into the formula. So if I want to find half the sine of 60, So this is going to say half the sine of 60. Let's just see if this works. If I plug in 1 minus the cosine of 60 over 2, I should get 1/2. Let's see if this works. Well, to get the sine of 1/2 of 60, all right, it's going to be equal to 1 minus the cosine of 60 is 1/2 over 2. Well, how do we do this part right here? Well, if you remember, if I'm subtracting fractions right here, let's drop this under 1 and make it easier. And then let's do a little crisscross applesauce. Remember, crisscross applesauce, subtract fractions. So that's just 2 times 1 is 2, minus 1 times 1 is 1, and then 1 times 2 is 2. And this is all over 2. Now, what do I do with this? Well, since I'm dividing by 2, I have to put 2 over 1. And then, because I'm dividing by a fraction, I'm going to flip it. So follow me all the way over here. And let's try it again. So what we could do is rewrite this as 2 minus 1. This part right here is just 1 over 2 times, and if I flip this over, be 1 over 2. Well, since I'm just multiplying that, this will be 1/4. Right? 1 times 1 is 1, 2 times 2 is 4th. And I'm taking the square root of 1/4. Well, how do I simplify? What is the square root of 1/4? A way to simplify, I'm not sure if you guys remember this. You could actually rewrite it like this. The square root of 1 over the square root of 4. Right? The square root of 1 is 1. And the square root of 4 is 2. So what we've done is said the sine of half of 60, the sine of 1/2 of 60, which is 30, is equal to 1/2. So apparently this formula does work. Once again, I'm going to say, can you prove half the cosine of 90, which is going to be the cosine of 45 degrees, is equal to square root 2 over 2? Try that using the formula and see if you get the right answer, right? We know this is the right answer. Try using the cosine of 1/2 of 90 and plug it into the formula and see if you get the right answer. All right, let's look at the problems that you're going to be doing today. This is really what your homework is going to be focusing on. So let's just take a look at these. We have these first two beginning. We're going to start with the double angles, okay? We know that if theta is an acute angle such that the sine of theta equals 5 over 13, what is double or sine of 2 theta? Well, all we have to do is really plug into our formula. So to find double whatever this angle is and what that trig value is, we would just do the sine of 2a, the sine of 2 theta in this case, is equal to 2 times the sine of theta times the cosine of theta, right? Well, the sine of 2 theta is actually 2 times the sine of theta, which we know is 5 over 13, times the cosine of theta, but we don't know what that is yet. How can we get it? Well, if you remember, if I want to find the cosine of this angle, we draw a little triangle. So here's my triangle. Remember this? I do this. We're going to say that this is theta, right? We know the sine of this, or the opposite over the hypotenuse, is 5 over 13. And if you remember from yesterday, if we have 5 and 13, we could use the Pythagorean theorem, or just remember that this is 12. So I could just say that this side is 12, and if I wanted to find the cosine of theta, it is the adjacent over the hypotenuse. That's 12 over 13. So I could just plug that in now. So it's going to be 12 over 13. So the sine of 2 theta, well, I just do 2 times 5 times 12, and that's 10 times 12, which is 120, over, now don't multiply everything by 2. Remember, this 2 over 1. 1 times 13 times 13, which is 169. Can we reduce this? Can't do that. Let me think. Nope, it can't be reduced. And it happens that this question, the answer is just number 4. Boom. That's all you had to do. Now, if you're still a little confused, let's take a look at one more. Let's look at this one. If we know the sine of a is 1/3, what's the cosine of 2a? Well, if I want to find the cosine of 2a all I need to do is square the cosine of A. Do I know what that is? Not yet, but I can in a second. Minus sine squared A. And since I know sine A is 1/3, I could just plug that in. So this is 1/3, and don't forget the squared. Now, as usual, I have to find out what cosine squared A is, or just cosine of A. So we draw our triangle. We say that this is A, right? It's opposite over hypotenuse. And we got to find this third side. Now, this isn't a special triangle. We can't do anything fancy here, so we're going to have to go back to the Pythagorean theorem. And this is 1 squared plus b squared equals 3 squared. 3 squared. 1 plus b squared equals 9. If we do this correctly, we should get b squared equals 8. And that would mean if we take the square root, b equals the square root of 8. Okay? So now we know this is square root of 8. So the cosine of this triangle, the cosine of A, is equal to the adjacent, which is square root 8, over 3. Now we can plug that in. So the cosine of 2A is equal to the square root of 8 over 3 squared minus, well, we already know this, 1/2, 1/3 squared. Now this is just where we do the math. So the square root of 8 squared is just 8 over 3 squared is 9 minus 1 squared is 1 over 3 squared is 9. That gives us a final answer of 7/9. And that is our answer, which happens to be right over, yeah. Let's keep going with our lesson. Okay, so now we're going to take a look at the half angle. That was the double angles. Let's look at the half angle identities. Well, if I know that x is a positive acute angle and cosine of x is 1/9, what is the cosine of half of x? Well, if I want to find the cosine of half of x, I just look up my formula, and my formula tells me if I want to find the cosine of 1/2 x, I'm going to have to do plus or minus the square root of 1 plus the cosine of x, which we already know. We know what the cosine of x is. They gave it to us. It's given the question. 1 plus 1/9 over 2. Now, yes, we hate fractions, but luckily we can just drop a 1 under this and do crisscross applesauce. So if we do that, I'm going to make it nice and big. We do 9 times 1 is 9 plus 1 times 1 is 1 over 9, and that's all over 2. Now, remember, it makes it a lot easier if we drop 1 under this because this is a fraction. So we're going to do this, flip this, and divide it by 2. So follow me over here where I could get a little more room. So if we simplify this, we get 9 plus 1 is 10 over 9 times, we're going to flip this, 1 over 2, which gives us the square root of 10 over 18. Now, since this can be reduced, we're going to have to do a little reducing because we look at our answer choices. Nope, nothing there. We have to do a little extra math. So what we're going to do is rewrite this 10/18. That can be rewritten as 5/9. Right? I just reduced that fraction. 5/9 can be written as the square root of 5 over the square root of 9. And I could just simplify the bottom here, and that becomes the square root of 5 over 3, because the square root of 9 is 3. And that would be my final answer. So really, if you could just plug in and follow the steps here, which do get a little messy, you'll get your answer. All right, I'm not going to go all the way through this one with you, but if we know the cosine of theta is 1/8, we want to find the positive value of the sine of half theta. Well, let me just tell you this. All you're going to have to do is plug in, but I'm going to let you find out what the answer is for yourself. So it's going to be 1 minus the cosine of A, or cosine of theta, which is 1/8, all over 2. And you guys have to do this all on your own. All right? Good luck, and I hope you learned something.